So the command word here is evaluate, which means write an answer as a number. Come up with a numerical answer for each of these questions. So some of these you could maybe do in your head, and some of them you will not be able to do easily in your head. But this is what you're imagining. Right? When I'm asked to find log 5 of 3,125, I imagine a little question mark there. I'm looking for the exponent. 5 to what exponent is 3,125? And sometimes this will be easy as seeing it on your powers chart. This one is just off of our powers chart. I don't think we wrote this down as a power of 5. So a formal way that you can go about solving these is very similar to how we solved exponential equations earlier. But it's going to be introducing something for our exponent. So you have to say, if you want to use this technique, like some people can just see the answer, that's perfectly fine. But if I introduce let x equal this, then I can use the definition of a logarithm and I can change it to exponential form. Now, often if this was non-calculator, then it would come from your powers chart. The number's a little bit big. If you went to your calculator and you tried 5 to the 5, you'll find out that it was just 1 off of our powers chart. But that means that we could write this like this. This side is 5 to the x, this side is 5 to the 5. And we used this technique before. If we can write both sides with the same base, then the exponents have to equal. And in this case, that would mean x has to equal 5. Okay. All right, B. In B, again, if you can see the answer and write it down right away, perfect. If you can't see the answer right away, then I would say write out let x equal this and change it to exponential form. So the base is 6, the exponent would be what we're trying to find. 6 to the x equals 1 over 216. This one is on your powers chart. 216 is 6 cubed. What can I do with that 6 cubed on the bottom of an equation? I can use my negative exponent law and move it to the top. And then, so x would have to equal -3. Yes?
Is it mandatory for us to write the slope part?
Technically, because we're not really doing any math, like we're just observing. Like usually you do a math thing to both sides to get x by itself. But since we're using an observation, I like that there. If you just wrote x equals -3, I'm not going to take off marks. Okay. But it's because we're technically not doing something mathematically to both sides. Because usually what you do to one side, you do to the other. And there's no mathematical thing that we're showing that we're doing. So then part C, this one for sure, I think it makes sense to say let x equal this, because it's not intuitive. 8 to what exponent would be 2 cubed root 2? Not easy to figure out. So I'm going to write let x equal log 8 of 2 cubed root of 2, and then change it. Base is 8, the exponent is x, to cubed root of 2. And then I go to my powers chart. Are all of those in the same column of your powers chart? Yes. They are all powers of 2. So I could change the 8 to 2 cubed. I could change the cube root to 2 to the 1/3. Now before I can use the so part, both sides have to be the same base, a single power with the same base. Well, that side will be 2 to the 3x. And what's your exponent law for multiplying with the same base? add the exponents. So we'll have to do 1 plus 1/3, which will be 4/3. Then now I can say that 3x has to equal 4/3. Divide by 3, which is the same as multiplying by 1/3. And I get x is equal to 4 9ths. Circle questions 4, 7, and 9.